Hey everyone, it's time for some chapter 6. We're going to jump right into 6.1 on radian measure. When you think of radian measure, it's just another way to describe the measure of an angle, and it has some uses in real world applications, especially if your input is like time and that sort of thing. It's a great way to tackle those types of problems. So we're going to do it. First thing we got to figure out is what is a radian? And this picture helps. So you have a radius of r, and the angle is such that the arc length on the circle is r, right? So if those two are equal, r and r, then the angle is said to have a measure of 1 radian. Okay, so if, for example, the arc length was 2r, right, then the radian measure would be 2 radians. And to generalize that, then we could think of it as a formula. It's just a ratio of the length of the arc compared to r. Okay, and we can use that fact to do some conversions from degrees and some common degree measures into radians. Okay, just to get our head around it. So what about the radian measure equivalent to 360 degrees, right? So 360 degrees is all the way around. So there would be the angle, right? And let's say this has a radius of r. Then it's using this formula. The s would be the length here, and the r is the radius of the circle. Now the length around the circle is also called the circumference of the circle, which has a formula, 2 pi r. So when I'm solving this problem right here, the top is 2 pi r, that's the arc length, divided by r, and we have r's canceling, and we're just left with 2 pi. So I could fill that in right here. 360 degrees is equivalent to 2 pi radians. It's a good one just to know, right? And then the rest are just going to be in proportion to that. So the one I'll go to next is 180 degrees, because 180 is half of 360, right? It would just be half of the circle. And I could just then divide by 2, right? 360 divided by 2 is 180. So 2 pi divided by 2, 2's would cancel. I'm just left with pi. So 180 degrees is the equivalent of pi radians. That one is a good one that we'll use for the rest, right? Now to jump to this one, I'll skip the 270 for now, but 180 divided by 2 is 90. So I just got to take pi divided by 2. And I don't want to get in a decimal approximation. I'm just going to leave that pi over 2. Okay. Blow this up a little bit. Okay. How about 180 to 60? That would be a divide by 3, right? So take pi divided by 3, and that's just pi over 3. Okay. And then finally, how about 30 degrees? That's 180 divided by 6. Right? So divide pi by 6. Pi divided by 6. Okay. So that's most of them. How about 270? What would be an easy way to get that? Maybe use the 90. All my arrows here. Because 90 times 3 is 270. So take pi over 2, multiply that by 3. That's 3 times pi over 2, which would be written as 3 pi over 2. All right, so all of these are useful to know. They come up a lot throughout the semester. So if you're familiar with those conversions, it will help a lot. Like 90, you just kind of think pi over 2 radians. It's really quite helpful. Okay, moving along. Now, what about just in general? I mean, we just kind of work that out with our brains, but is there a method? Yeah, if you want to convert from degrees to radians, you could just multiply by pi over 180, and that works, right? So let's do this example down here. I'm going to take 120 degrees and just multiply that by pi over 180. The reason this works is because that's pi pi radians per 180 degrees, right? If I put the labels in there. And then notice what happens is the degrees cancel and you're left with radians. Okay. Now this one, it does say, simplify your answer, give an exact answer using pi as needed. So I want to leave pi alone and just reduce that 120 over 180. Right. Well, it looks like 30 divides evenly into both of those. So you're just going to use your reducing fractions method, right? Or if you want to use some technology, since I know you already know how to reduce fractions, if you want to save some time, use your calculator for that. Most calculators can reduce fractions, scientific calculators, that is. If I show you the one that I use, let's clear this. So if you can see my screen, we can do this. If I take, so I ignore the pi, I just need to reduce this fraction 120. I use my division 180, right? And then don't hit enter, but go to math, which then has this frac button. It's already highlighted, so I'll hit enter and then one more enter. And then it reduces to the correct fraction, okay? So if you don't have the TI-84 or similar, your calculator probably has that feature. You would just have to look it up. But anyway, that's a lot about reducing fractions. But anyway, it's just a time saver. So if you want to use it, you can. If you're quick at reducing fractions in your head, then you probably just fast forwarded through all this. Okay, so let's go back to the handout. And it's 2/3. So the way I'm going to write this one is 2 pi over 3, or 2/3 pi. Okay, and that's my final. Okay, so let's try another one. 315 multiplied by pi over 180. Oh, it's a negative 315. Doesn't really matter. It's just my answer is going to be negative. And I know what happens. The degrees cancel. I'm left with radians. So it's really, this one just is about reducing that fraction 315 over 180. I'll do it one more time with the calculator. So 315 divided by 180. Don't hit enter, hit math, enter, 7/4. Okay, and that's pretty neat. Okay, so this one's going to be negative 7 pi over 4. Okay. Next one, 690. And we get the system now, just multiply by pi over 180. And I got to reduce 690 over 180. However you know how to do it, go for it. I'm using my handheld calculator now, just real quick. I'm getting 23 over 6. Okay, so this would be 23 pi over 6. Final. Okay, the next examples are the same directions, convert each degree measure to radians. However, notice now it says give the answer as a decimal, approximating to the nearest thousandths. So these aren't so nice, right? Just 278. So in this case, I'm still doing the same first step, multiply by pi over 180. However, I want to give an entire decimal answer here. So in your calculator, you're going to use your pi button and get an approximation. So let's see, on mine, it'll look like this. I'm going to take and do 278 times pi. So my pi button is here. So I got to hit second, that button. Okay. And then divide by 180. So use your pi button. Every scientific calculator has a pi button. The way you type it in might look a little different, but there's our final answer. 3 decimal places is the nearest thousandth. So that's 4.0. 852. Final answer. Okay. The other one, I'll just stay on the calculator and just tell you the problem that's next is 47 degrees, 35 minutes. So if you have a angle that has some minutes involved, you can tackle that with your calculator by doing this. So I'm going to start with a parenthesis, and the way I'm going to type in this angle is 47 plus 35 divided by 60, which we did back in chapter 5. Okay, and then close the parenthesis. That is the same as 47 degrees, 35 minutes. Now I'm going to do times pi over 180. Okay, so it'll give me that overall decimal. And that's my final answer, 0.830. So approximately 0.830. And we're good to go. Okay, so we're moving right along. Hope that is clear enough. If not, let me know and I'll help you out. Okay, back to the handout. What about the other way? So we're going to convert now from radians to degrees. So that's also in that box above, right? Convert by multiplying by 180 over pi, right? Okay, makes sense because we just want the radians to cancel. Okay, so each of these are in radians. We're going to convert to degrees. So I'm going to take 3 pi over 4 and multiply by 180 over pi. And hey, that's cool because we have a pi up top and a pi below. Pi's are gone, right? Pi's cancel. And then I just have to work out this fraction problem, 3 times 180 divided by 4. I could just do that in my calculator. So I could even do some canceling if I want, or however you want to do that one. There's a few different ways, right? But it's just a fraction problem. But 3 times 180 divided by 4 is 135 degrees. Okay, and there it is. All right. Next one, negative 17 pi over 10. I'm going to multiply that by 180 over pi. Pi's cancel. And now I'm just going to take 17 times 180 divided by 10. And that's 306. Okay. So this is negative 306 degrees. Okay. Finally, 6 pi. 6 pi times 180 over pi. Get the red. Cancel those pi's. If it helps, think of this as over 1. Right? So there's nothing to divide by. It's just 6 times 180. So 6 times 180 is 1080. So we're going to do 1080 degrees. Okay. One word of note about the units of measurement. If it's degrees, you definitely want to put the degree symbol, the little circle. Right? If it's in radians, you don't put anything, right? So notice all of these. If there's no unit of measurement, it's assumed to be radians. That's really important for these problems down here. This 2.88. How do you know if that's in degrees or if it's in radians? If it's just sitting there like that, you know it's radians because it does not have the degree symbol. Okay, so like this whole number 6, is that 6 degrees or is that 6 radians? It's radians because it's blank. All right, so a little word of caution there. Otherwise, this one we have to convert from radians to degrees and do some rounding, round to the nearest minute. Okay, so I'm going to do my same work, 2.88 multiplied by 180 over pi, right? But here, there's no pi canceling, right? Because my original angle was not in terms of pi, so I don't have that pi canceling. I need to do an approximation. And I'm going to do this all in my calculator. So let's bring that up and let's see how this works. So I need to do, okay, I'll start typing it in, 2.88, right, times 180 divided by pi. and that's 165.01 degrees. Okay, now this one does say write your answer to rounded to the nearest minute, which means it wants you to take this one step further and convert that fractional portion of a degree to a minute, right? Remember how to do that. You got to take that decimal portion, 0.011845, and just times it by 60. And then round that to the nearest whole number, which would be about 1. So that fractional portion is 1 minute. So this one, the final answer is 165 degrees, 1 minute. Okay. Let's try the last example where it's 6. So multiplying by 180 over pi, so 6 times 180 divided by pi. Okay, hit enter on that, and that's the degree measure. But then we have to convert that fractional portion to a minute. So just take the decimal part off and times it by 60, because there's 60 minutes in a degree. And that's about 46 minutes. So this one, the final answer is 343 degrees and 46 minutes. Okay. All right. Cool. So let's go back to the handout, see what else we got. And I've put the answers in the handout. Here they are. I gotta circle my answers. There we go. Okay. 2 pages down. Now the next page in your handout, there's nothing to do. It's just for reference. So this one, here's a nice image of pretty standard angles in degrees and in radians, right? All the way around 360 degrees. So it's a good reference if you want to use that throughout the semester. If you print out anything, this is a pretty good one to have. Okay, and it's good to just start getting used to those measures, and even memorize them would be pretty awesome. Make your life easier going forward. Otherwise, that's a good stopping point for now. So I'll do in the next video the next page, but there's pages 1 through 3. We're on a roll. Here we go. Moving on with chapter 6. Hope all is well. Send questions my way if you have any. Talk to you later.